I won't do 1 and 2 for you. 1 and 2 you should already know how to do from 8-6 part 1. We're going to have motion problems today. We're going to have work problems today. And we're going to have mixture problems today. So those are the problems from the notes. And then I just kept their empty charts here if you want to copy and paste them. Just so you're aware, you are going to need to have these charts memorized or know how to use them come the test time. All right, let's read number 3 together. Excuse me, number 3. So I did the answer key, and then I was like, I hope the kids know everything they're supposed to have. So I highlighted everything that's important. Did you print the one that's blank? Just making sure. Let me see. Good. Okay. Number 3. You can travel 40 miles on your motorbike in the same time it takes your friend to travel 15 miles on his bicycle. If your friend rides his bike 20 miles an hour slower than you ride your motorbike, find the speed for each bike. So the question becomes, out of this yellow, would you guys say this is a motion, a work, a mixture, a proportion, or a similar figure? This is a motion problem. Very good. So I did put them on here today. I'm going to do a quick pick up like that and a copy. Those are motion problems. I'm going to do a quick paste right here. Let's just go through and put everything in their appropriate spots. Where do you guys think 40? Wait. What are the 2 labels? Good. All right. Where do you guys think 40 is going to go? It's a distance. Do you think it's a distance for the motorbike, or is it a distance for the bike? Good. What did we refer to in the notes when I said it's same time? And what does that mean for our chart? T. Good. And now your friend has 15 miles. Where does this go? Good. Bottom here or here? Good. If your friend rides his bike 20 miles an hour slower than you ride your motorbike, translate that into math. What's that? Yes, I'm going to use r minus 20 because r is right, but you can absolutely use x minus 20. Where does that go then? So we have r minus 20, x minus 20. Where does that go? What's that? No, actually, because it says it's his bike is 20 miles an hour slower than his motorbike. So that means the bike gets the minus 20. And what would that make the motorbike then? No, just R. Good. I'll make the equations with you, and then we'll move on to the next one. Okay, please don't solve them yet. Let's just get them all set up. Can anybody make me an equation for the motorbike? Good. Can anybody make me an equation for the bike? Good. All right, I'm going to pause there because you can if you could just do your math, your normal math there. If you don't know how, just watch the example. But let's do number 4. How much pure orange juice must be added to a current 15-liter 60% orange juice mixture to create a 70% orange juice mixture? What are the yellows do you guys think this one is? Just talk. I have this heater on. Could you talk a little louder for me? Mixture. All right, so that means I'm going to need to have this chart ready to go. And where do you think I put, what do you guys think about this 15 liters? What's that? Top of the first one. Yep, it's the amount that you have. of the first, like what you start with. So like you have like a bucket or a bucket. I like how I said bucket. You have like a container with 15 liters of orange juice. Okay, what do you want for the 60%? Where should we put 60%? Yeah, of that 15 liters, it's a 60% mixture. All right, give me some more. What do you guys think about this 70%? What's that? Not the bottom. Not the bottom of the second. It's actually the bottom of the third because that's what you want to create. The word create is kind of like an equal sign. All right, and then somebody take a look at the notes or the example that I posted from the notes up above. Tell me what goes on the missing. I need something here and I need something here. Excellent. Yay! Wonderful job. And then I'm going to make a single equation, and then we'll move on. What's the equation? Oh, and I'm sorry. Can we also, maybe I jumped the gun. 60% is what as a decimal? Yes. And what about 100? Good. And 70? Good. Okay. Now, I also jumped the gun because I didn't ask anybody for the total amount. My bad. I got so excited. What's the total amount equation? What's that? 15 plus x. Very good. 15 plus x. All right, now I'm ready for the equation. I was way too excited about how good you did there. Okay, tell me what the equation would be, please. Remember, it's going to be incorporated of these yellow highlights. All right, when you're ready, go ahead. I'm going to turn this heater off. That way I can hear you better. No, you actually don't. It's weird. Like the reason we study this in this unit is because like 60% is technically a fraction, which is why they consider this a rational expression, but it's almost like very misleading. Wonderful. And then you'll saw that that's actually just an algebra 1 problem now. I'm going to go to number 5. So there's not a double variable. That was just like straight up distribute, solve, which is kind of nice. Oh, I'm sorry. I meant for that to be highlighted in yellow. I guess, again, that's what I get for working at 11 or 10 o'clock last night, I guess, huh? Had to go get Lily at the end of the day yesterday. Okay. Why not just, let's everybody just get sick at once. All right. Mike is an experienced bricklayer. He can build a wall in 3 hours. His son, who's learning, can do the same job in 6 hours. How long does it take for them to build the wall if they work together? Do you guys think that's a mixture, a work, or a, what one do you think it is up there? Mm-hmm. Very good. So I'm going to go steal this work chart. The work chart is probably the one chart I don't actually need. It's a chart I changed. I used to use a different chart. Kids never understood the different chart. I thought, okay, maybe this one is a little more user-friendly. This stuff might actually be, work problems might actually be very instinctual for you. Okay, what are the 2 items I have? What are my 2 labels? Mm-hmm. What do you guys think about, what do you guys think about this 3 hours? Yeah. But dear old Mike's gonna give a 3. What about this 6? Mm-hmm. All right. That's like actually all they gave us. Um, what is the part of the job that Mike's going to complete? Mm-hmm. What goes here? What goes here? A couple people today have gone up here and looked at the examples. Yeah, I would like some of you are just sitting waiting for other people to go do that. Yeah, I was like, let's not do that. Let's good. Mm. Mm-hmm. What's that T stand for? Time. Yes, that's what that T always stands for. Sometimes you know that T. Sometimes they're like, hey, we did our homework together and it took us 30 minutes. You know, it takes Mrs. Langeli 60 minutes. How long would it take whoever else is working with her? Sometimes your variable's in a different spot. All right, what's the equation then? Good. Good. And then you have, from yesterday, you have the skills to solve that. All right, let's get number 6. So apparently I did highlight that one. The okay. This problem. The aerodynamic covering on a bicycle increases a cyclist's average speed by 10 miles an hour. God bless you. The time for a 75-mile trip is reduced by 2 hours. Determine the average speed with and without the aerodynamic covering. Do you guys think that is motion, work, mixture, proportion, or similar figure? Very good. So I'm going to go steal that motion chart up here. What do you guys think are it's very important to know like what 2 items we're doing. What are the 2 items or 2 situations that make one trip different than another? Was one on a bike and one on a train? Yeah, one with the covering and one without the covering. I had to look this up once because I thought it was like, what's an aerodynamic covering on a bike? It's just funny. It makes me giggle. I'm definitely going to show you. This makes me giggle every time I look it up. I don't know. It's neat. I don't know why I think it's silly. There's one that looks like a spaceship. This is the one that I think of. I mean, like, I guess, right? Because it does like reduce like the wind and stuff. I don't know. I always just thought it looks funny, but I guess it probably works, right? It's like it's probably like having more of an aerodynamic car than another. Where am I at? Right here? Okay. All right, like I know like I don't know. Okay, stop talking to me. Let's take a look at this one. What do you guys think? I'm just gonna highlight a whole phrase. I hope you see the whole phrase, but this is one. Something increases by 10 miles an hour. What does that 10 miles an hour is associated with an increase? Whoa, took my glasses off and things just went crazy. X plus 10. What is increasing by 10? I'll write X plus 10. I will accept X plus 10. And I'm going to ask you, where in your chart do you think that goes then? The rate with the one with the covering. So my only very mild complaint is I would like to use R, because then to me that makes me like indicate like it is a rate. I don't mind if you use X. Okay, that actually, bless you, that actually tells us something else. Keep going. Yeah, that's right. Now some kids ask, can I do minus 10 here and then just keep that at R? 100%. That's like the same thing. That's fine. I like working with positives, so I'm going to do that instead. All right, let's take a look at this 75 mile an hour, or excuse me, 75-mile trip. Where does that go? For Yes. Oh, I got very excited there. Yes, because the length of the trip is different. He's taking 2 trips that are 75 miles. Just, yeah. Yes, because the width the cover does make it go faster. So your time is decreased by 2. That is correct. Yes, and you guys can probably see, oof, look how much harder that first equation is going to be than the second equation. So which problem did I copy from the notes? See this one from the notes? That one, the math is more algebra 1-ish. And then I did one with my husband that was more algebra 1-ish. And then I did one with my husband that's more algebra 2-ish. This one's going to be more algebra 2-ish, okay? To screenshot the other one and shrink it to fit would have been obnoxious. So just take a look at that one. Let's get the first equation. This is the one with the cover. Who can tell me the first equation? Good. Tell me something you probably implied, but I didn't write because I didn't hear it. Yes. And then let's take a look at number 2. I feel like I'm going to get you guys started on this one after we set them all up, because this will be your hardest algebra one to solve. Good. All right. And then let's go to number 7. What? Kevin wants to keep his heart rate at 160 beats per minute while he's training. During his workout, he counts 27 beats in 10 seconds. The question first is, how many beats a minute is this? Do you guys think that is motion, work, mixture, proportion, or similar figure? It is a proportion. Yep. One thing compares to the other. There's no distances, there's no jobs that are getting completed, and there's no shapes or percentages. So it's almost a process elimination. All right. Let's get the equation set up. Oh wait, first of all, the question says how many beats per minute. That was a little misleading, so I added this part to it. Well, how many seconds would that be? Wait, no, I'm sorry. Right here, just 1 minute. My bad. That's what I was. Yeah, see, that's what I was looking for. You had it. What for the 27? All right. Tell me how to set this up then as a proportion. You guys know from algebra 1 that's a proportion. Use the given information to fill things in. What 2 things relate? That is what he wants. It's not necessarily what he did yet. But keep going. Like, take a look at that sentence. This is his goal. This is what he tracked. So tell me about that. What's that? Good. So that you just indicated that you want to put the beats over the seconds. That's what I heard from you. So that means you're going to put your beats on the top, and you're going to put your, and we did this in chapter 2 when we were reviewing algebra 1. We did this in 3 if you need more assistance here. I also did one of the notes, but it was like giving Tylenol to a kid, which I still do to this day when my girls are sick. As they grow, you can like look at like the baseline, and then if you make your proportion, you can give them, you don't have to just give 7.5 milliliters or 10, you can give like 8 depending on their weight, because it's all proportion to how big they are. Same thing for like us right now. Like Zach, you might be able to handle more ibuprofen than my body, right? It's kind of the way it works. Like they take a look at your weight and you can proportion them. Not at all. Nope. I'm just like, 5'2" and you're like 6'1". I mean, they could put me in a linebacker in football, but I don't think that would be a great idea. Pretty sure I would be demolished. Okay. What do you guys think then about that 60 seconds? Where should that go? Yes. Which would make this our unknown. And then now we have a rational expression that actually, without even knowing in algebra 1, you were doing rational expressions. Okay, number 8. This one I kept from last year because I've changed a lot because this lesson needed it. Okay, this one I kept it because it threw kids off because it has a sneaky wording, but sneaky wordings are like a real thing. So let's take a look. You can paint a fence. You can paint a fence twice as fast as your sister can, Working together, the two of you can paint a fence in 6 hours. How many hours would it take each of you? Okay, so what kind of problem do you guys see? Okay. I'm going to go grab the work one that we had last time, and I'll do the one that's filled in. That way we can kind of see it one more time, use an example. Okay, so we don't have Mike and his son anymore. What do we have? Yeah. So let's fill these out. What do you guys see for what do you guys see about this 6 hours? What's this 6 hours represent? Together time. So I'm going to put that right here in the together time. So that one's not T this time. What about you and your sister? What do we know? Oh, I love how you did. Yeah, you can go twice as fast as your sister. So it says number of complete hours. Number of complete hours to the job. That's weird. That should say number of hours to complete the job. That's like a really weird phrase. That number of complete hours to the job. Oh, good. It didn't sneak you. A lot of kids will give you the 2x. But that means that you take twice as long. Right? It's worded. That's what I meant by it was worded sneakily. Now, I like what you said, Hannah. I'm just instead of like because over here, if we did it, we're gonna have to have 1 over x 1 over x over 2. Do you know what I mean? Like a double fraction. So we could just do this instead. But like what you said was not incorrect. Right, to do it this way. So whenever you're setting these up, give the longer person the extra coefficient. So your sister takes longer, so give her the extra time. I bet you if I would have put I would have put your sister was twice as long as you, then you would have no issue with it. But like you saying you're twice as fast as she takes twice as long, it's the same phrase. It's just sneaky. Okay, what part of the job are you going to complete? And what part of the job your sister? And together? Okay, and then the equation? Not quite. Look at this one. Give that a quick comparison. Yes. Good. I know I'm not going to solve them all, but I just want to, especially with the half day, I want to make sure you guys know the common denominator on this one. This is a problem from yesterday, but I think there would be probably lots of questions on this one. What would you guys see as the common denominator here? A 6 and an X is correct. Yes. Now let's talk about what they're missing, and then I'll go to the next one. What is the first one missing? 6. What's the next one missing? Super weird, super weird. A 3. Yeah. Because, like, yeah, it already has the 2. 6 divided by 2 is 3. And what's the last one missing? No, it has the 6. The X. Good. Maybe you said that and I heard 6. Okay. If you guys were like, boy, that was stupid and I don't like it. If you wanted to include an extra 2, you could have, but then this would have changed to 6 and 2. So I like just doing that. If you can understand that, I think that's easier. All right. Then it goes into a problem from that now it's a problem from yesterday. You can go from there, hopefully. Pick one. In the following exercises, use the map that's shown on the map. Atlanta, Miami, and New Orleans form a triangle. Whew, that took me a long time to read that sentence. Yeah, it's a similar figure. You did this in geometry. On the actual distance from Atlanta to New Orleans was 420 miles. So that's the real distance. Find the actual distance then from Atlanta to Miami. All right. Go back to geometry. Let me hear a nice little proportion for your similar figures. What would you do? There's like 4 different answers. Go ahead. What would you do? That will do it because you're doing miles over inches, these two over these two. And then common denominator is 3 and 2.1. Last one. This one, it's so weird. I've had so many kids do this differently over the years. There's two equations you could make that are very, very fine, and they actually reduce to be the same thing. So when we make this equation, think about it as if it was a group of us, if it was our class going. You're planning a school field trip to a local theater. It costs $60 to rent the bus. Each theater ticket costs $5.50. Same as Miss Angela, you don't have like that yellow highlight thing up there. Actually, I don't. You're right. It is a rational expression. This is actually a review of something we did in 8.2. We did a word problem like this in 8.2. Okay, so I wanted to get some memory recall back. Write a function c of x to represent. Look at what we're going to represent. Good. Good. What do you guys think? I keep like hovering up. What do you guys think? Okay, if it was our class, we have okay, that's good. That is one way. 550 times x plus 60. That's going to give what? What is that equation going to be? So like say that's the total with the bus. So how do we figure out how much you owe? If I have the total of the trip, how do I figure out how much you owe? If we want it to be even. Yeah. That's right. There it is. That's the equation. Good. I was, if we could like kind of think about it, like when I made if you were look at my answer key, I do this. I go, well, each student has to pay $5.50 and they have to share the cost of the bus. It doesn't matter. I don't care how you do it. Like this is what my brain does. This is kind of where you guys went. And both of those are the exact same thing. Because if you reduce yours, you get this x cancels and this keeps the x. So it's like it's the same exact thing. All right. And then the next, so there's your equation. You can get rid of mine. Unless you like mine better, your brain saw it that way too. That's fine. How many students, that's x, must sign up if the cost is to be no more than $10 per student? So what does 10 go in for? Sorry, the C of X. Good. I like that you guys seem to be understanding this is like one item. So if this is the cost, we're going to delete it. And that's where the 10 goes. Now, just so you guys know, you're going to get a decimal answer here. When you do your work, you should get like 13.3 when you do your work. Okay. So what do you guys think in terms of students? Should we put 13 students or do you guys think the final answer will be 14 students? Right. If you only have 13 people, yeah, it's gonna be like 10.50 or 10.60 or $11. It's gonna not be. It's gonna be too much. We want it to be 10 or under. So that's why we have to go up to the 14. All right, these are not needed. They're extra. They're not even all from last year. This one was from last year. Everything else I just found more online that I thought these are cool. So if you're struggling with work, I have a work problem here, another distance problem. I did a proportion problem, and there are extra problems if you want. I found them all from. There's like a free website that actually has free Algebra 2 book. I got them all from this, so I'm not gonna take credit for all of them, but it's a free open source website, and I was like, I'm not gonna reinvent the wheel. All right, that's that. I did say, I'm not sure if you guys remember, I want to do the super hard problem or at least get it started. My biggest concern is going to be number 6. That's where I see you guys coming into the most issues when you solve. Okay. In the notes, what variable did I kind of like isolate on each equation? And number 2 is, I'm going to focus on this equation first. But do you remember what variable I got? I wrote it like, I either wrote R equals or T. Go up and take a look, you'll find it. So I'm not even in that example way up top, the one I copy and pasted. Yeah, got T by itself. Now, how do we get T by itself? Good. Now, I did that one first for a reason. Definitely easier. We're going to go venture into the other one. That one's going to create a few issues. So let's go venture in over here. Okay, so our goal is to get T by itself, which means I got to get this whole thing by itself first. So how do I get that whole thing by itself? What should I do? Good. Excellent. You're going to divide by r plus 10 on both sides. All right, go ahead and tell me the result that we get there. Yeah, that stuff, huh? Yeah. Good. I'm going to do that free form grab there. Oops, not that much, Amy. There we go. All right. And now the parentheses are totally useless. Tell me how to get T by itself now. Add 2. Now, I can add 2 over here with no problem. And I'm absolutely certain you guys can too. However, when we add 2 over here, let's talk about this little add 2. Do you guys think it goes with the 75 to become 77? Or does it stay in the back? Or does it go in the denominator? Goes in the back. Can't put it with the denominator. Or, excuse me, that was totally misstated. Can't put it in the numerator because it doesn't have a denominator of r plus 10. So it's separate. And it deserves its own big space, I think. All right. Now, so we get our equations, we isolate T, see how T's by itself. Well, by the transitive property, what statement can we make? Is really like substitution. What statement can we make by the transitive property about these two things? Well, they both equal T. Yeah, it's more or less that they both equal T. Like, think back to algebra 1. When they both equaled Y, what did we do? That's what you need to do. Yeah. So it's just like algebra 1, super pumped up. And then the good news here is that we did these yesterday. So this is now a yesterday problem. What would we do yesterday? What was our first step yesterday? Yeah, and we should check if the denominators factor. Do they? No, our denominator. Good. All right. So what is our common denominator? Can we remember from yesterday? I like the R and another R plus 10. I think some people think it's just R plus 10, but why do we have to include the R and the R plus 10? Binomial, monomial. Yeah, they're both like very uniquely different because they both are different types of polynomials. There you go. That's a good sentence. What does the 75 mean? Good. What does the other 75 mean? And here's why this is the hard problem. What does the 2 need? Yep, that is why this particular problem is the worst on today's homework. Okay? Because you're going to get an R squared. I'll ask you question by question by question, okay? I'll do my job, and all I'll do is say, what's next? So, what's next? Mm-hmm. Not quite. Close though. Good. I'm going to take a step before that right here. Okay. I'm just going to go one step behind you. That is correct. What is next? Good. Good. And one more. Yikes. I'm going to just take one step behind you. Good. And now I'll apply the steps that you guys had. What would that? She correctly said this. So I guess I can write it since it's already been said. Tell me what to write after that. Good. Give me a sign in front of the 75R. And then you did correctly say that. I'm going to go ahead. Since you did say that correctly, I'm going to write it. I hesitate to skip that step prior because that's where mistakes happen. Yesterday, my last block, a lot of kids were skipping that step. It cost quite a few of them to have to redo the whole problem. So, especially with their negatives. It's not so bad when they're positives. When they're negatives, though, it's pretty bad. Okay, tell me what we do here. Good. Tell me what to write. Good. Yep. We will factor it, but not until we set it equal to 0. How do you guys want to set this puppy equal to 0? Okay. I would like that very much. Do you remember that order, what that's called? She's rocking out. Does anybody remember that order? It's a quadratic equation now, and is it in vertex form or standard form? Standard form. Yeah. All right. What do you got? You could do the quadratic formula if you want. I just think that while we're in chapter 8, I think it's a really good idea for us to practice our factoring. So what's the first step to factoring? Good. GCF. What would be left? Could. You sound like me. I was doing this answer key last night and I was like, I had to get my calculator out. All right. And then I definitely got my calculator out for this. Go ahead and give me some. This is an algebra 1 factoring problem now because like there's a 1. So if you get your magic numbers, those are your numbers in your parentheses. Yes. Just remember, I'm going to skip like the box and the grouping step because I'm going to put it in red. Because that's 1, I can skip box and grouping. Now, if that was like a 3 or if that was like a 2, if it was anything but 1, I would have to do the whole thing. Maybe some people we haven't heard too much from want to participate. Okay, so those are good. Excellent, excellent, excellent. What do we do now? Good. And this still, oh, look what I lost. I lost my equal 0 the whole way down. I made an expression when I did that, which is, it's not an expression, is it? Now what would we do? What would, and solve, yeah. So set them equal to 0 is what I heard. Then solve. So what's R? Good. What do you guys think? Like, let's pause. We definitely have one of those is legit. If this were just math, we'd be done. Our answers would be done. But this is a word problem. So what is R? Positive 15. I like that one. So we did, let's see, we did our equations, we did our work, we have our answer. What's the statement? Who can answer the actual question? And maybe you need to look at this to answer the actual question. What if I did a quick little like swoop and duplicate and move that puppy over here? You're getting it. Good. Now my question is, why did you pick let's see. Good. So she says down here she picked the positive 15 because you can't pick negative for unless you're only going backwards, but don't do that. Don't even pretend that's a thing. And then so up here, R was plain in the without. So our answer was 15 miles per hour, right? Not kilometers or anything. I think it was miles per hour. And then you said width was 10 bigger than that. There you go. So everything's been set up. There are no notes tonight. So your only homework is to finish this up. I'll be here till 3 today. I'm not sure what time you guys leave this class. I'm assuming it's pretty soon. Okay. So you have everything set up. You have everything. It's just a matter now of executing the problems.